everyone. I'm DAC Cadet Queenie Tachada, and now I'm going to share you my insights about these four following topics, which are the dead reckoning, the estimated position, the running fix, and lastly, the fixed position. So first is the dead reckoning. The method of dead reckoning, which was utilized by Columbus and other mariners of the age of exploration, was a common navigation technique before the advent of satellite navigation. As I perceive from this topic, it is an effective way to estimate a vessel's position based on its previous location, speed, and the direction of movement. By tracking the ship's compass heading, speed, and the time spent on each heading and speed, navigators could determine the route and distance covered by the ship. Additionally, dead reckoning is a useful in determining sunrise and sunset times and predicting landfall and arrival times among the other things. There are rules in plotting the vessel's DR positions, which are first, at least every hour on the hour, second, after every change of a course or speed, third, after every fix or running fix, and lastly, after plotting a single line of position. Notably, DR is denoted by a semicircle or an arc, and DR time is written diagonally. However, it is essential to acknowledge that this technique can accumulate errors over time and is therefore not always accurate. So now is the estimated position. The estimated position, also known as EP, refers to an approximate location that is determined using a variety of sources of information, such as GPS data or visual references. Essentially, the estimated position is the DR position that has been adjusted or corrected for the effects of external factors such as the current, wind, steering error, and other variables. The process of calculating the EP involves drawing a vector from the DR position in the direction of the set, with a length equal to the product of the drift and the number of hours since the last reset. It's important to note that an EP should be plotted and evaluated with every DR position, and that the direction of a straight line from the last fix to the EP is what is referred to as the estimated track made good. To represent an EP in a chart, a small square is typically used with the time written horizontally. In conclusion, the EP is a critical component of navigation that provides an approximate location based on multiple sources of information. By calculating an EP, navigators can make necessary adjustments to their course and ensure that they are on track to reach their destination. Therefore, understanding how to plot and evaluate an EP is essential for safe and effective navigation. So now is the running fix. Based on my understanding of this topic, running fix is a navigational technique that is utilized to determine a vessel's position by taking bearings of a fixed object or landmark from different locations over time. The process of obtaining a running fix involves taking a bearing in a fixed object or landmark, using a compass or other navigational instrument, and recording both the time and the bearing. After the vessels has moved to a different location, another bearing is taken on the same object or landmark. By comparing the two bearings and taking into account the distance traveled and the time elapsed between the two observations, the navigator can estimate the vessel's position. To refine and improve the accuracy of the estimated position, this process can be repeated multiple times. It's worth noting that running fixes are often used in conjunction with other navigation techniques, such as dead reckoning and celestial navigation, to provide a more comprehensive and accurate picture of the vessel's position. Additionally, running fixes can be particularly useful in situations where the vessel is moving too quickly to take a single fix in a celestial object or in areas where the availability of fixed objects or landmark is limited. In conclusion, the running fix is a valuable navigational technique that enables the navigator to estimate the vessel's position by taking bearings of a fixed object or landmark from different locations over time. By utilizing this technique, alongside other navigational tools such as the dead reckoning and celestial navigation, navigators can ensure a more accurate and reliable determination of their vessel's position. So now we are in the last part, which is the fixed position. A fixed position in navigation is a highly precise location that can be determined through various navigation techniques. It is regarded as the most accurate and reliable method for determining a vessel's location and is widely used in marine navigation. Since at least two methods of position fixing should be used, thus, it is essential to identify the primary and secondary methods of position fixing for each leg of the journey. When in open sea, GPS is the primary method of position fixing and celestial fix serves as a secondary method. However, if there is a conspicuous object visible on radar, then the primary method of position fixing would be the radar fix, and the secondary method would be the GPS. And if the object is also visible, the primary method becomes the visual fix, and the secondary method would be the radar fix. Moreover, there are various methods to determine a vessel fixed position, including the cross bearing method, the cockhat method, bearing and distance of the same object, bearing and range method, distance of two or more points, and the bearing and distance of different objects. In the cross bearing method, two LOPs are obtained from taking simultaneous bearings of two suitable charted objects, and the LOPs should intersect with each other. In the Kakat method, three LOPs are obtained from taking simultaneous bearings of three suitable charted objects, which usually creates a triangle. However, if the position lines fail to intersect at a point and a Kakat results, it means that error occurred due to various reasons the such as error in plotting, poor survey of the area, and so on. Note that the larger the Kakat, the larger an error in one or two or all of the position lines is likely to be. In addition, there are ways to reduce errors while determining a vessel's fixed position. When taking distances, it is recommended to take it from ahead or astern before taking distances on the beam. Conversely, when taking compass bearings, it is recommended to take bearings on the beam first before taking the bearings of the ahead or astern part. So, this concludes my insights about these four following topics. So, thank you for listening.